Hello. Today we'll be looking at step 3, 2006, question 7. Okay, so right, let's get started. So firstly, we need to solve the equation. This quadratic involving hyperbolic function. So it's not too bad. Let's get started. And so we can see that, well, we could do something like completing the square for the first part. Okay, so completing the square. Remember that cos square x minus sine square x is 1. And so we have our result. And so u plus sine x is equal to plus or minus cos x. And so u is therefore minus sine x plus or minus cos x. Okay, so not too bad. The next part 1, says that we need to find the solution of the differential equation that satisfy the provided conditions. Okay, so we can see that, well, this equation they give us is literally replacing u with dy by dx. And so we can solve this, and we can straight away solve this. We can therefore say that, well, dy dx, which are denoted by y dash, is equal to minus sine x, plus or minus cos x. Okay, so this is what it could be, but now we need to take a look at the boundary conditions. And so we're told that y must be 0, x equals 0, and y dash must be greater than 0 when x is equal to 0. So we can see that if there's a negative sign here, then when x is 0, y dash will be minus 1, which is not greater than 0. So we have to reject that solution. Okay, so we can say that y dash greater than 0 when x is equal to 0. So this implies that we only take the positive portion. Okay, and so we can rewrite it like so. Okay, and the rest is something that we not so bad. So we can integrate both sides, and so we get sine x minus cos x plus c, and then we need the boundary condition that when x is 0, y is 0. Okay, and then this implies that c must be 1, and so y is sine x minus cos x plus 1. Okay, so that's part 1 done. Let's take a look at part 2. Part 2, we need to solve, we need to find a solution not identically zeroed of the differential equation that. Okay, so not identically zero, it means that, well, y can't be 0. So because y equal to 0 is technically a solution to that differential equation, but we can't pick that one. Okay, and then satisfies x equals 0, y is equal to 0, and express your solution in the form of cos y is equal to f of x. Okay, so this is quite interesting because, well, usually we're going to get an equation in terms of y is equal to f of x, but they ask us to give it in terms of cos y is equal to f of x. So that straight away says to me a potential substitution that can make our lives a bit more simpler. Okay, and so let u equals to cos y, and that's what I'm thinking. Okay, so let u to be equal to cos y. Okay, and then this will imply that du by dx is equal to sine y dy by dx. Okay, and so now we can substitute the above into our original equation, which is this. Okay, so we substitute the u and u dash into our differential equation, and we should obtain the following. to u dash over sine y, and minus sine y is equal to 0. And so we can see, well, actually, this cancels out with this, and so we times both sides by sine y, we will get u dash squared plus 2u dash minus sine square y is equal to 0. Okay, and so when you get to this point, don't panic, because what's going to happen is that if we complete the square in the first part, we're going to end up with a minus 1, and then we have a minus 1 minus sine squared, which then we can use to get cos squared, and which is u. Okay, and so this actually works out quite nicely in our favor. Okay, so let's see. So let's complete the square. So bear in mind we want our function in terms of u and x and not y, and so this is the final part. And so u dash plus 1 all squared is equal to cos square y, which is u squared by our substitution. And so u dash plus 1 is therefore equal to plus or minus u. Okay? And so this means that u dash is equal to minus 1 plus or minus u. Okay? And now let's think about the boundary conditions within our substitution. We need x equal to 0, y is equal to 0. When y is 0, cos 0 is 1, so u is equal to 1. Okay? And so let's solve this following. Okay? And then what we're going to realize is that one of the solution we must reject. Okay? And so we have du by dx is equal to minus 1 plus or minus u. Oh, so the one that we're going to reject is going to be the one that is when it is positive. Okay, the reason being that if you do sort of work it through, you find that you're using the boundary condition you're going to find y is equal to 0. Okay, so I won't go through, but if you let it positive, you will find after some algebra cos y is equal to 1. This implies that y is equal to 0, but we want to reject that one. Okay, and so we're going to consider the negative. Okay, and so that if we do that, this is du by dx is equal to minus 1 plus u. Okay, and then you should get something like minus 1 over 1 plus u du is equal to x plus some constant, which is minus natural log of 1 plus u is equal to x plus c. And so natural log 1 plus u is equal to minus x minus c. 1 plus u is therefore some a constant e to the minus x. And so u is minus 1 plus a e to the minus x. Okay, and we're using the condition that when x is 0, u is 1 because y is 0. Okay, and then we should obtain that capital A is 2 using this condition, and so u is therefore 2e minus x, e to the power minus x minus 1, and so therefore cos y is equal to 2e to the minus x minus 1. Okay, and so that is our solution. Now let's take a look at the final part of the question, which is slightly a bit more trickier. So show that the asymptotes to the solution curve are y is equal to positive slash negative minus x plus the natural log of 4. Okay, so first thing first is to consider what do we mean by an asymptote. An asymptote is what the curve roughly look like when the magnitude of x and magnitude of y approaches infinity. Okay, so there kind of are two. So we want to sort of talk about what happens when x approaches infinity, x approaches negative infinity, what happens when y approaches infinity, and similarly y approaches negative infinity. Okay. Now, first thing to realize is that actually if x approaches positive infinity, then e to the power minus x approaches 0, and so cos y approaches minus 1, which is contradiction because cos is always positive. And so actually we just need to consider when x approaches minus infinity. Okay. And another thing to realize is that so y can approach positive infinity, and similarly y can approach minus infinity. Okay, and since cosh y is a even function, right, for all y, we can just consider when y approaches, say, positive infinity, and then slap a positive and minus sign on the right hand side to give our final solution. Okay. So as we work through to see what to actually see what we mean by this, okay. So let's firstly write cosh y in terms of our exponential form. So that is e to the power y plus e to the minus power y over 2 is equal to 2e to the minus x minus 1. Okay. Now, firstly, let's consider as y approaches infinity and x approaches minus infinity. Okay, so if y approaches positive infinity, then e to the power of minus y will approach 0. And so this equation will therefore look roughly like e to the y is roughly 2e to the minus x minus 1. Okay, so e to the power y is therefore 4e to the minus x minus 2. Okay, and so y is therefore natural log of 4 e to the power minus x minus 2. Okay, which is roughly y is equal to what, natural log of let's take the 4 out. Whoops. Let's take 4 out, and so that is natural log of 4 plus natural log of e to the power minus x minus a half. Okay. Now we see that, well, actually, as x approaches minus infinity, e to the, so let me try to write it. As x approaches minus infinity, e to the minus x minus a half approaches simply e to the minus x, right? And so therefore y is roughly natural log of 4 plus natural log of e to the power minus x. Okay, so y is roughly natural log of 4 minus x. Okay, and so this is one of our asymptotes. Okay, so our asymptotes we are looking for, one of them is minus x plus natural log of 4, which is what we found here. And so so therefore, similarly, actually, as y approaches minus infinity and x approaches minus infinity, we simply slap a minus sign in front. Okay, so y is roughly minus natural log of 4 minus x. Okay, and so therefore the asymptotes are y is equal to plus or minus natural log of 4 minus x. Okay.